Back in the lab now, and we're going to take a look at total internal reflection. On the desk, we've got a ray box, we've got a semicircular glass block, protractor, slit plate, pencil, and ruler. Let's get going. Okay, so in this experiment, we're going to use a semicircular glass block. Place it in the center of an A4 piece of paper, and again, trace around it. This allows us to move the glass block out of the way when we need to make measurements and we need to plan our rays coming in. Okay, now importantly, take this out of the way, grab a ruler and mark the absolute center of that. Okay, take your time at this measurement, this is important. So this one's what, about 9.4, divide that by 2, 4.7, place there and mark it. This is the center of your block. This is extremely important to get right. Okay, so as with all of our other ray diagrams, we take our protractor, set the zero line along the base of the semicircular glass block and mark 90 degrees. This allows us to construct a normal, a 90-degree line that's going through our center point here, because this is where we want to aim the light at. Okay, after that, we need to mark out some angles. So let's take quite a small angle at say 10 degrees, a mid-range angle of about 40, one at 60, and then maybe one at 80 for this one. So we've got 10, 40, 60, and 80, like that. Connect these points up to your center point. Now this looks very similar to the rectangular glass block refraction pattern. The reason that we're using a semicircular glass block is that when the rays of light originally strike our glass here, you would expect, because of refraction, for these to change direction. But because this is a semicircle and it's being aimed towards the center, the ray of light is coming in at a tangent to that piece of glass, which means that the angle of incidence is 0 at this point here. The angle of incidence is 10 here, but 0 up here. So it will travel straight through here, being undeviated, and then reaches here. Okay, so it allows us to, basically it allows us to create light that we're in control of inside a piece of glass that's then attempting to leave the glass. Okay, so we need to get some rays on that. Okay, so we replace our glass block onto here as accurately as we possibly can. Turn our ray box on again with the single slit and move our ray box into position along the 10-degree line. Now, we're not actually going to make any constructions on this one, we're just going to note what's going on. We have our ray of light coming in, it's travelling straight along through the glass block and is emerging here in much the same way as we would expect. We have the ray of light speeding up and bending away from the normal. I just want to demonstrate that to you. If the ray of light was to travel completely straight, then it would be along this path, but because there's a glass block in the way, we can see that that has slightly deviated off that path. So we have it moving further away from the normal than it would have ordinarily. Exactly what we would expect in this. Probably not visible on the camera, so we'll maybe bring this a little bit closer, see if we can get a bit more intensity. There is a very, very, very weak reflected ray here. If we move our way round to the 40-degree mark, again we have a situation, it's a little bit more obvious now that the ray of light is coming in straight here and striking there. If it was continuing straight, it would probably go along the line of the pencil, but it's being deviated much further away from the normal here. And we have a slightly stronger reflected ray coming out here that it's struck here and bounced straight out. So we've got a little bit of reflection. Coming around to the 60-degree angle, life gets very interesting. We have a situation now where we have no ray down here whatsoever, and we have an extremely strong reflected ray here. This is total internal reflection. We have a situation where no refraction is taking place whatsoever. All of the light is being reflected off this surface here and being sent back through here. It has been totally reflected internally in the glass. Total internal reflection. The next thing that we want to do is, there's obviously a changeover point. At 40 degrees, we have an emergent ray. At 60 degrees, we have no emergent ray. Somewhere in between, we have a situation where we only just have an emergent ray. So let's put some markings in and see if we can find that exact position. So here we have an interesting situation. We've got our ray of light coming in, we've got a refracted ray coming out, and it's actually been split into its constituent colours because we're starting to see red bands, yellow bands and green bands, and we have a very strong refracted ray. This is our last point really at which we're going to get refraction. This is known as the critical angle. Okay, so whatever this angle is here between our normal up here and round to here is called the critical angle C. At the critical angle, the angle of refraction is 90 degrees, because remember, this is our zero line here, and our ray of light is now travelling along the surface and out this way. So this is 90 degrees. Whilst this bit here is still okay, there's definitely a ray of light that's coming along here because we've got some serious splitting of light going on. We've got a very strong reflected ray, and if we come beyond this critical angle, our emergent ray disappears entirely and we have total internal reflection.